The moon has a tail. The moon has a tail, and Earth passes through it every month. Most of us grow up thinking we know what the moon is: a silent, grey rock, airless, inactive, a world so simple that we can sum it up in one glance. But that picture is wrong. The moon is quietly leaking atoms into space all the time. Sunlight pushes some of those atoms into a long tail that streams away from the moon like a comet. And once every month, around new moon, Earth moves into the geometry of that tail as our planet's gravity squeezes part of it into a brighter, denser core. The moon, in other words, has a tail. And that matters for more than the novelty. It reveals that the moon is not just a dead rock sitting beside us. It is part of a constant exchange between sunlight, dust, impacts, atoms, gravity, and space itself. Even our closest cosmic neighbour is more dynamic than it looks. To understand why the moon has a tail, you have to start with something even stranger. The moon does have an atmosphere, barely. NASA describes it as an exosphere, which is really a polite way of saying there are so few particles that they can travel long distances without colliding, even with each other. Per cubic centimetre, the moon's atmosphere contains about 1,000,000 billion times fewer molecules than Earth's. If you stood on the lunar surface, you would not feel wind, see haze, or experience anything that resembles air. But that does not mean nothing is there. Among the trace ingredients in that exosphere is sodium. Not sodium in the everyday table salt sense, but individual sodium atoms sitting on or near the lunar surface and occasionally getting kicked loose. Some are freed when micrometeorites strike the moon. Some are released when the solar wind and sunlight interact with the uppermost grains of lunar soil. The moon has no thick atmosphere and no global magnetic field to shield it the way Earth does, so its surface is constantly exposed. Every tiny impact and every burst of energy at the surface can knock atoms upward. Most do not go far. Some fall back down, but some get enough speed to escape the moon's gravity altogether. And once those sodium atoms are free, sunlight takes over. This is the part that sounds almost fake until you picture it properly. Light does not just illuminate matter, it can also push on it. For sodium atoms escaping from the moon, solar radiation pressure nudges them away from the sun. Over time, that push stretches the escaping atoms into a long anti-sunward stream. Not a dusty comet tail, not a glowing ribbon you could see with your eyes, but a huge, faint tail made of atoms. That is the basic mechanism. The moon leaks sodium. Sunlight pushes it. A tail forms. But the weirdest part happens when the geometry lines up. Around new moon, the moon sits roughly between Earth and the sun. In that configuration, the sodium tail extends away from the sun and into the night side, where observers on Earth can detect it with instruments tuned to sodium's glow. At the same time, Earth's gravity bends and focuses part of that flow, compressing it into a denser region beyond our planet. Researchers describe this as a bright spot or dense core in the tail. So this is not just a tail trailing off into space in some abstract direction. Once a month, the Earth-Moon-Sun alignment makes part of that tail easier to detect, and Earth interacts with it gravitationally. And this is not just theory. The distant lunar sodium tail was identified in observations associated with the 1998 Leonid meteor shower, and the tail appeared brighter after that shower, which helped reveal how strongly impacts can affect the moon's exosphere. Later work showed this was not some one-off event. Long-term observations published in 2021 described the moon's extended sodium tail as a permanent feature. It is always there in some form. The monthly geometry just makes parts of the system stand out. That permanence changes the tone of the whole idea. The moon is not occasionally making a tail. It is living inside a process that continually sheds and redistributes material. And that process teaches scientists something useful. Because the lunar exosphere is so thin, it preserves clues about what is knocking material off the surface, where those atoms came from, and how they move once released. NASA's LADEE mission and later analyses showed that sodium and potassium in the lunar exosphere vary across time and location, with strong signs that meteoroid bombardment and surface composition both matter. In plain language, the moon's tail is not just a curiosity. It is a record of how the moon is being weathered by space. That is an important shift in perspective. On Earth, weather mostly means wind, water, clouds, and rain. On the moon, weather means impacts, radiation, charged particles, and the slow loss of atoms to space. It is a harsher kind of weather, but still weather in the broadest sense. The tail is one of the visible consequences. There